Hello, welcome back to Ready Controls. Have you ever written structured text that compiles perfectly, but the machine behaves completely wrong? Most beginners think this is a syntax problem. It is not. It is a data type problem. And in this video, I will show you exactly why. In the last video, we learned about structured text syntax. Now we are moving to the most important beginner topic, variables and data types. By the end of this video, you'll understand why code that looks right behaves wrong. Now let's switch to Studio 5000 here. For this, before we write any structured text, I'm going to create a few tags that I'll be using in this demo. So let me do that first. Go ahead and create some tags. We will create I've created a start PB BOOL tag, which is a program scope, and fault underscore active. All these tags that so what we did is we created, so I will use multi-line. So we created all these tags for the purpose of this demo. Okay, I just made this as a PB1 BOOL. Okay, these are all the tags that we will use for this demo. Tags for this video. Yeah, and you can highlight them. So now what we're going to do is, why tag creation? All these tags are program scoped. They're only used. The reason for the program scope is just want to show the behavior. These are only used inside the structured text routine, and they're not shared with other programs or tasks. And it's always safer to use program scope for beginners. And program scope prevents accidental cross program writes. The tags I'm creating here are program scope. That means they only exist inside this program. And for structured text routine, this is the safest and cleanest by default. Only move to controller scope when data truly needs to be shared. When do you want to create controller scopes? When you want the tags to be shared across, when you want the tags to be used by the HMI, or when you want the tags to represent a physical IO, or when you want a tag to be part of a system status or a mode control, you create a controller scope. Example like auto mode, e-stop OK, all these tags can be so tags like this, like auto mode, e-stop OK, these can be a controller scope. Don't use controller scope just because it's easier to find. That's how the last project was, or I always do that way. Scope is part of your program design. If you don't control the scope, your PLC project controls you. So what is variable? A variable in a PLC is not just a name. It has three things. It has memory, data type, and scope. These are the three main things for a variable. Memory tells us how much memory to allocate. The data type tells us how much memory to allocate, how the math works, and how comparison behaves. If you choose wrong data type, the PLC will still run, but it may behave in a way that you did not expect. So let's, without any delay, let's start looking at each of the data types. So we have a BOOL data type, which is strictly a true or false, right? That's a BOOL data type. And the correct way to work with BOOL is, if you have a motor run command, motor run 1, which is our command, if you want to evaluate an expression and assign a value to that, you use the assignment operator, and we use a start push button 1, which is the BOOL, and not of fault active, right? And then we end an expression with a semicolon. So that's how you use a correct BOOL logic. What we are trying to say here is this motor run will be high when start push button is pressed, when this goes high, and there is no fault active. This is a clean and readable structured text. And you could put comments, motor run will be on when start PB is pressed and no active faults. So that's how you can do expressions using bool. Common mistakes I see beginners doing is we use something like if condition and we use a motor run equal to 1 then, right? So this does not work. Then say output 1 equal to 1 and then we say end if, right? When we go ahead and execute it, you can already see we have an error here in this line because motor run is a bool, right? A bool is not a number, so you cannot assign a 1 to a bool. Instead, the correct way to redo this one is if motor run, right? What we mean is when this condition is high, the if statement will work and then do the action after the then. So never treat the bool as, so never treat booleans like integers. Okay. Next we'll talk about integer data types. Studio 5000 gives us a lot of integers like ascent, int, DINT. DINT gives us more range and protect us from silent overflows. Int and ascent can overflow without warning and PLCs won't tell you. So for the ranges you could see my previous video, or I'll just drop the ranges right here. Alright, so just let's assemble this one and see what errors we get. If you can see we got 3 errors. Let's look at line 18. Line 18 says expected colon. We missed this assignment operator which is a colon, and then go ahead and assemble it. Let's see if that takes care of the error 18. Now error line 19 needs a semicolon, so we put that and we assemble that. That took care of all the errors, right? Even though that's the tricky part about structured text. Even though the error was not related to this rung, it gave error to this line. Okay, so that's how you handle DINTs in. The reason for using this DINT number, this variable as DINT, is to help us give us a longer range. So let's monitor the counter number, counter underscore DINT. Okay, and you can see as long as the structured text is executing, the counter keeps incrementing, right? So that's how you do use DINTs. Integers and ascent can overflow without warning and PLC won't tell you. That's why keep using DINT as a default choice. Now let's work on the next data type, which is a real data type or a floating point number. And this is where many beginners get burned. Real math behaves very differently than integer math. For example, I have a result underscore int, and we want it to get a value from the expression, which is 5 divided by 2, right? So what do you think will happen when we execute that? So we'll go ahead and assemble it and monitor the tag in result underscore int, and you can see it's behave differently. Since both the operands are integer, so the PLC performed a integer division. The result is 2, no warning, no error, just the wrong answer. To fix it, the best way to do this one is, instead of using result integer, let's use result real tag, which is a floating point, and we use divide by 2, 5 by 2. And now if we look at result underscore real, you'll get the right number. Or say I don't want to use this way, I just want to represent, say if we just edit it, I can just say 5.0 divided by 2.0 and assemble it. My result is still 2, right? But instead, that's because my value is integer here, right? So let's see if we can do you could also do like a real of phi divided by